December. All right, cool. So it's my pleasure actually to announce the next keynote speaker from Google. I mean, he has been working on the object-oriented virtual machine, even on Java hotspots. He has actually also developed on the Chrome JavaScript engine V8, and of course he's the co-founder of the Dart language. And you know, if he's not working on the runtime languages in the evening, he really likes to study Austin Powers to work on his Dutch accent. It's my great pleasure to introduce you, Lars Bak.
Good morning, everybody. We're here to talk about shaping the future of web development. It might be a little bit too much of a title, but let's see how it goes. It'll be exciting this morning. We will have an announcement of a new system, and we will have cool demos being shown. So let's get started. I don't know much about Belgium, but since I watched Austin Powers, I know what a Belgian dip is. So this morning I went to a coffee shop to get a latte and did it with a nose. They didn't recognize it, so it's not very good, but I hope you can appreciate the picture from Austin Powers. Let's start with the talk. First of all, you all know the web has been exploding, especially over the last 5 years. Part of it is that browser technology has become faster and more widely standardized. One thing I'm proud of is that running JavaScript inside a browser is close to 100 times faster today on the same machine as it was 5 years ago. I hope you all noticed that. And it's not only one browser, it's all browsers. The whole industry has been lifted, and there's a nice competition in that area. Well, if you give developers speed, you know what happens? They write more complicated code and gobble up all the resources. That's also happened on the web. However, one thing I have noticed is that the programming language and the tools for the web, they are still the same as 5 years ago. And we want to change that. And what we've also seen in developing V8 is that there's a bottleneck when doing JavaScript on the web. And we are trying to address some of it today. Here's a graph that shows you how big the web is and how it has increased over time. I would expect that in a few years that more than 90% of the population will be using the web. It's amazing. You access it from your smartphone, from your tablet or your desktop, but it's all web-based. I always like to tell this story about my kids because kids today, they get a new computer, you give them a computer and they start up a web browser, but they don't use any other applications on the laptop. So compared to when I was young, you install a lot of native apps. Today it's all about web applications. So companies doing apps, they are focusing on web applications unless it's on the Android platform or iOS. So let's go on to the next slide. With all this power we're getting in web applications, programmers are getting hungrier and hungrier to do more stuff on the web. For instance, they want to do WebRTC, so they can do Hangout-like applications. They want to do 3D graphics, so they can do modeling inside the browser. And also, they're demanding smooth animation, so you can do kind of games in the browser. On the right, you'll see a picture of a cool app. We just discovered that last week. It's a Hangout kind of application where you can, in a distributed fashion, do jam sessions and make songs over the internet. Pretty cool, all written in Dart, of course. Next slide. Let's go back and look at current development tools and obstacles. So this is certainly colored with my personal opinions, but I believe that JavaScript is a bottleneck to writing structured applications. I hope some of you agree with me. This is mostly a Java crowd, so if you disagree, you can shout. Thank you. We did V8, And in doing V8, we debugged a lot of JavaScript code. And one of the problems we saw was there was a lot of errors in JavaScript code. And it was not because the programmers were lazy. It's because the system is very forgiving. You can put in a spelling error in an attribute, and the program still runs. It does the wrong thing, but it still runs. And I think that's not very good for getting a stabilized application and product ready. So that's one thing. Another thing is with JavaScript, there's no real consistent set of libraries. Often you have to pull a library jQuery from one side and another library from another side. And some of them are made by doing monkey patching of the underlying objects. And when you combine them, sometimes you get conflicts. And you have to resolve that yourself. Last one is that you don't have really good tools. If you're lucky, you have Emacs or VI to figure out who called what. And one of the reasons for that is that JavaScript is not declarative, right? The way you set up an application is by executing a large script. And when you're done executing that script, you have the application. The problem with that is you cannot go back to the source code and see what is the program. At least it's very hard. And we would like to tackle some of that. So here it goes. We have been working on this open source project, Dart, for a long, long time, more than 2.5 years. And today we are taking off the beta label. It's 1.0 and it's ready to be downloaded. I just heard that the bits were ready a little bit before 9, so you can download it now and exercise the Wi-Fi system here at the conference. The whole purpose of this platform is to increase programmer productivity. So if you really want to be faster at writing the application, you should check out Dart for writing web applications. And we think it's the coolest thing ever. The language is great. It's very familiar. If you have a background in Java or C# or even JavaScript, you can pick it up in a few hours and use it. So hopefully it's to your liking. So here's the website, dartlang.org, and you can click on download it, and you can see how it works. So what is Dart? First of all, it's a new structured programming language. It's very easy to learn. And one thing we like about the web is this instant gratification. When you do a change to your program, you can reload the page and you can see the change, how it affects your program without going through a complicated tool chain. I guess you've all tried Java-C. Sometimes it can slow down your development process. One thing that's special about the programming language is it's very familiar if you are from the Java side. You have classes, interfaces, mixin, and so on. But you also have an optional type system. So if you don't like static types, you can just write in your code and run it. And this is great for experimentation or prototyping. But as your application moves into a phase where you want to have more structure and nice library interfaces, you can add the static types and even check it for static type errors. We have a rich set of libraries that work together, so you can easily combine several libraries without they are colliding, which is nice. For all Java programs, that should be sort of common mode of operation, but we have that in Dart too. In addition to the language and the basic libraries, we also have a complete IDE that's based on an Eclipse system. So there you can do static type checking, you can do completion of names, and also debugging and refactoring and stuff like that. At the end, the most important part is that you can translate Dart into JavaScript, and it'll run in all modern browsers. So we are not out to fragment the web. We really want to work with the web, and one way to do that is to make sure that our system runs in all browsers. So just a little bit of background. You heard before that we've been working on HotSpot and V8, and Our core fundamental belief is that if you make stuff really, really fast and consistent and robust, programmers will like it. I hope you remember when we introduced HotSpot. I used to work at Sun. It went from a time where people were questioning Java because it was too slow and would it ever go anywhere. When we introduced HotSpot, all that discussion went away. So performance fix issues. And the same happened with V8 when we reduced that. Suddenly stuff got really fast, and the slowness of JavaScript was sort of in the past. We're using the same philosophy in the Dart project, where we're trying to make it as fast as possible when you execute your program, but also when you start up your application. I've been spending too much time working on these systems. So 27 years I've been working on virtual machines for object-oriented languages. Many of the languages I've worked on, they're dead now, but still, there's a lot of history, and that is sort of culminating in the Dart system. Hopefully, you'll find it fast. Here's a quote from a developer that have been using Dart. This is this sound trap system from Sweden. We just learned about it last week. And this is Björn Melinda talking about why he liked the Dart system. I'm not going to read it for you. You can read it yourself. But the bottom line is you should trust him and try it out. We didn't pay him to say this, by the way. Next slide. The reason why Dart is interesting for Dart developers is that if you're used to doing Java, where you're used to classes and libraries and so on, it'll be a very easy sell. And it runs perfectly on the web. One thing that you might find when you try Dart compared to Java is it's more condensed. So you don't have to write all the import statements. And you also have shorthand notations for functions and so on. So it's very compact. And by the way, we put in closures from the beginning. It was not that hard. Can you go back again? Yes. So this pretty much says it. So I think the feedback we have gotten for Java programmers so far is that you can be productive very, very, very quickly. Of course, you have to learn the libraries. They're different than the Java libraries. But within a day or two, I think you should be able to write your first small program that's doing something interesting. Let's go. So let's check out the system. So let me introduce Kasper Lund, who is the guy I designed this language with, and he'll give the first demo of the Dart programming environment. Take it away.
Thank you very much. So let's see if this thing works. I'm going to switch over to the Dart editor, which is our IDE. This is not the only option you have for writing Dart code. It's one solution. There is IntelliJ plugins and support for other editors as well. But this comes with the platform, and it's very easy to use. So I'm going to use this for demonstrating the system. What you see here is a very small 2D animation application that runs in the browser, and I'm just going to show you how it looks before I dive into the code, so you have a feel for what we're talking about here. And let me start it up. Here you see it. It's not that interesting, maybe, but at least it's a very simple demo, so I can do some tweaks to it, and you can learn a little bit from that. Let me go back to the code. Here it is again. So I hope you guys in the back seats up there can sort of see the code. Shout if you cannot. I'll assume you can. Otherwise, you'll have to come closer, but that probably doesn't work here. Anyway, the sample is fairly simple. It starts with a bunch of imports of a few libraries. Maybe the most important one here is the StageXL, which is a community contribution through our package management system. So we have a rich ecosystem of libraries that you can use in your application. This one is a complete API for 2D content, games, rich applications. So I'm going to use that in this demo. You already saw it in action, so I'm just going to skip to the main function. which is right here in the middle of the screen. So hopefully, like the syntax for people with a Java background is simple enough that you can sort of understand the structure of it. You have functions here, main and animate, and execution starts at main. You don't have to put it in a class with a public static void main method. You can actually just write void main and off you go. The system starts out by creating a stage, and then it loads some bitmap data, the logo you saw animating. When the bitmap data has been loaded, it will actually complete a future, and once that future completes, then we'll actually call a callback called animate here with the actual bitmap data. So it's an async programming model that is familiar to most people working on the web. So we built that into the core libraries in the system. The animate function is relatively simple. There are a few things here that might require a little bit of attention. Mostly the dot notation, which might be a little bit unfamiliar to you. It's basically just a simple way of calling methods or assigning properties or reading properties of the same object in a nice, concise way. In other languages here, you would have bitmap dot, bitmap dot, bitmap dot all over. But here you can just do like a series of operations on the same object, and it's very, very convenient for setting up the state. It's basically one of those things that Lars mentioned, that it's a little bit more concise sometimes to write in Dart, and we really prefer that kind of thing. It gives you this desire to try to make your code look nicer, like cleaner, smaller, and it's from my perspective, it's a pleasure to work with that kind of system. So the rest of the function here is basically setting up the bitmap and then asking the system to do animations of the logo here. You'll see it starts out by basically asking for an ease-in bounce transition, and that's the sort of the bouncy effect you saw. I can try to change that, and you'll see what happens when we go to something a little bit more simple here. Let's do, let's see, linear. That's the one I want. Then I can save that. And without running any other tool, I can actually go to the web browser running here and just refresh it. And you'll see that the transitions on the where it scales up has changed, and it's become linear instead of this bouncy effect. But notice I did not have to compile anything. This is because we have a build of Chromium that comes with a native Dart VM. So it doesn't actually need you to compile it to JavaScript before running it, which is very, very convenient for development. We can go back and change a few more things in the sample here. We could make the bounce out go linear as well. Oops, that's not where the cursor was. Close enough. So you'll notice that if I do a spelling mistake here, the system actually highlights it. It might be hard to see on the back row, but it actually gives me feedback that this method or this function cannot be found here. So I can go and correct it. But this is actually different. Well, you'll be used to it from, let's see if I can actually move the cursor again. There we go. I can correct it. I can go to the browser. I just have to save. I just reload here, and hopefully the transition out will be linear too. So you get feedback if you type in mistakes. This is no surprise for people from a Java background, but for people working on the web with JavaScript today, even simple tools like that will really, really make you more productive. So using Dart for bigger apps and finding these issues at compile time or at analysis time rather than at runtime is a huge help. So the system is still running here. So everything in the editor is hooked up with debugging support and everything. So I can actually set breakpoints in here and see what happens. So if I put a breakpoint on this line, let's see if I can actually make it happen. There you go. It actually stops because it's still running. So the animate callback here is invoked at some point, and I can inspect the state, dive into the bitmaps and the state of the objects that are shown here, and it works just like you would expect. The nice thing, you're actually working up against a running browser instance, and it's very nice to have that kind of integrated development feel for that. Let's just stop this thing again and do a final change here. And we'll go back here again. And we can run it again. So hopefully we're back and have the sample running just as it was before. Now there's still a breakpoint in here, so I should probably get rid of that. I'll kill this one. I actually want to show you the code running on a few devices we have lying around, because it's nice that you can work with the Dart editor and code up against a browser that has an integrated native Dart VM, but of course it also needs to run across other browsers. So for that, we actually have the transition to JavaScript, and it runs on a couple of different devices I have here. One is an Nexus 7, so that runs actually the Android version of Chrome, and the other one is the Safari browser from Apple. So it's just kind of nice that you can write the same app and then deploy it across a variety of different devices. So all in all, the system is ready to use, easy to get going on, and it's easy to write these kind of simple things and deploy them to the web. Thank you.
So yeah, this was a great demo and it worked. Fantastic. We really believe in these fast edit run cycles. It makes programmers more productive. If you have to wait before you can run the program after you've done a change, you'll change the way you program. You'll be more defensive in your programming style. We want to go the other route. We want to make sure that within a second you can be up running the code, and this is what Casper showed you. So this is dear to us. That is the reason why we include the Dart VM in the Chromium build in the SDK. So when you do development, you get the fast turnaround cycle, and when you deploy it, it will be compiled to JavaScript, and you can use it on any browser. Now, can I go just back? Sorry. I just want to say that, so we included the Dart VM in Chromium. This is just the first step. Of course, the final step is to get into Chrome stable. So one of these days, you will suddenly find out your Dart application runs much faster in Chrome due to the Dart VM, but I'll come back and give a talk about that another good time. Next.
There we go.
So, it's always great to hear from the creators who did it, but it's better to hear from some of the projects that have been using our platform. So, we invited 3 projects to talk about their experiences of using Dart. And the first one that will join us on stage is Dan from Mixbook. He'll come up and give us a demo. Please give him a hand.
Hi, everybody. My name's Dan Schultz, and I'm the lead front-end engineer at Mixbook. Today, Mixbook and I are excited to announce Montage, a web application that we built using the Dart platform. With Montage, you can quickly create a photo book using our autofill algorithm and customize it using some simple tools. But before I show you a demo, I want to go over a few reasons why we picked Dart for this project. With Montage, we wanted to start our transition away from a proprietary platform and to the open web. But we didn't want to sacrifice the productivity that we were used to. So we started looking at tools to make this transition easier. And when we saw Dart, the team was really excited about its potential. It had a familiar object-oriented language, so we could pick it up very quickly. It has optional types, so we could better understand each other's code. But this also allows the tools to give us code hinting and refactoring support. Dart also has support for libraries and a package manager to manage these libraries. This made it very easy for us to both create a modular application, but also to include libraries that other developers in the Dart community had made. Lastly, Dart can be compiled down to JavaScript, so we could take the benefits of Dart and use that on modern web browsers today. So with that, I'd like to show you guys a demo. So here's Montage, or the editor portion of Montage. And this is a Dart application. It's been compiled to JavaScript. And in fact, all the elements that you see on this page are custom Dart components. So for instance, these images in the center here are responsible for taking the custom markup that our designers use to make these designs and translating that into an SVG document that's ultimately displayed by the browser. What's great about Dart is that we can reuse these components on other screens of our application to keep our view code very dry. So let me go ahead and pick a theme. I'll pick Magazine White, and I'll hit Save. Now, this is the customization part of Montage. So let me go ahead and jump into inside the book. And the same component that we were using on the previous screen to generate the SVG document is being used by this page flip component. So this page here looks a little bit plain, and I'd like to add another photo to it. So I can go down to the photo tray, select a photo of my girlfriend and I, and I'll just drop it in. And what's happening behind the scenes is that while the user is performing that drag operation, we are doing an asynchronous request to the server, and we're asking the server, with the photos that are currently on the page and the photo that I'd like to add, what is the best design that matches this content? And by the time that request is made, or by the time the user performs the drop operation, that data is ready to be applied to the project. So this photo here is zoomed out a little bit too far, and I'd like to zoom it in a little bit further. And I can pan it up. And what we're using for this is we're using CSS3 transforms, and this allows us to, or allows the browser to do subpixel rendering and makes that movement very, very smooth. So as you can see, we've been able to build a modern web application using Dart. And we at Mixbook feel that Dart is a great platform for building rich apps. If you're interested in Montage, please check out Mon.com. We're currently in a private beta right now, but if you give us your email address, we should be sending out invites shortly. Thank you.
Hello, I'm Thomas. I'm with a company called Blossom.io, and we provide a very lightweight agile project management tool for some of the world's leading software companies. And it initially was an all JavaScript code base of a couple of thousand lines of code, but a few months ago we heard of this new programming language and platform called Dart, and started to look into it and use it for fun projects on the side. And some things that we really liked with the experience that we had developing with Dart was its batteries included philosophy. So you basically have a very solid standard library that you can build on top of, and when you browse third-party code, it makes it easier to understand, feels more familiar, because everyone is building on common ground, and that's kind of the experience that you have from coming from Python or Ruby or Java, but it's not the case in the JavaScript world. Another part that we find really interesting about Dart are type annotations. So they basically help you make sense of your code when you come back to your own code base a few days later, or when you want to read other people's code. And in our case, since we were distributed across several time zones from Europe to San Francisco, they really make things more clear to you when you work on the same code base but are not in the same room. And another thing that we were really excited about, that were already mentioned, were Dart's great support for upcoming web standard called Web Components that help you make your code base more maintainable, and you can reuse a lot of stuff, as you will see in a minute. So basically we were in this situation where we identified a new cool technology and played around with it for fun projects on the weekend, but we really wanted to use it in production to do serious stuff with it. And I'm sure many of you are often in the same situation where you find this cool piece of technology and you really want to use it for real stuff. And I guess that's kind of the fun part of running your own company. You can just decide to use new good technology. And that's what we did. So we decided to migrate our existing JavaScript code base over to Dart. And that turned out to be way easier than we thought, because there's something called JavaScript interop, where you can call Dart code from JavaScript and JavaScript code from Dart. And we basically identified parts in our code base that were fairly independent of each other and started to migrate them over one after the other on a widget by widget basis. So there's here you see one of the first things that we moved over. It's basically a very simple login screen that was fairly independent of the rest of the application. And it's a very simple view. Oh, sorry. How do we make that? How do we make that visible? So there's a login screen. You see a very simple input field, a password field, a button, and a gravatar image. And basically, we implemented all of these little components as Dart web components so we could reuse them later. And then we moved on to a settings screen, and you see again the gravatar image and input fields, and we didn't have to re-implement those things. We could just plug in the components that we've already used. And then we went further, and basically you see things all over that you can just plug in and reuse. There's, again, these input fields, gravatar images, and eventually we started to do like overlays, a drop-down, custom, checkbox fields, and inline text editing fields. And you could basically just reuse the web components that you've already built. So once we had a bunch of components in our own Dart package, it's really easy, like in the supermarket, you just grab what you already have and can move faster. And by now, okay. So basically, if you want to see us live in action, you can go to the website, blossom.io, or come downstairs, visit us at our Dart booth, and I'm really excited to show you in more detail how our journey to Dart was. Thank you.
Hi. Whoa. A little further away from my face. Hey, I'm Brad Green. I'm an engineering director from Google, and I work in the ads group, and I manage a bunch of different projects. One of the projects I manage is an internal project called Green Tea. This is Google's Salesforce productivity automation test suite. And when it came time to build this suite again from the ground up, we picked Dart as the front-end language for building our UI. Now, in addition to having a great language on the front end, we wanted to build Green Tea on a solid, proven web application framework. It just so happens I also manage a web application framework called AngularJS that we've gotten some success with in the past. And so we ported Angular to Dart, and we call it AngularDart, unsurprisingly. Hey. So in this porting process, I have to thank the whole Dart team, Lars and Casper and everyone else. They did a fantastic job helping us build it in a way that was optimized for Dart, but also optimizing Dart so that it works well with Angular. Now, we in the Angular team, we took advantage of a lot of the cool features in Dart, like the class annotations, to make our own APIs more easy to understand and less prone to error. In addition to Dart's features, we've taken advantage of some cutting-edge web platform features like Shadow DOM to build what we think is the simplest and most powerful version of Angular to date. So in porting Green Tea, or in building Green Tea from the ground up again, our front end was composed of 12 web developers, and we were able to go from no code and really no understanding of either Dart or Angular and build and release the first product in 6 months. We were really excited about that. It's even more exciting when you think this was at the time when both Dart and Angular were changing incredibly fast, and we had to rewrite the application a couple of times to get it out. So we're incredibly excited with how fast we think we can go now that we've got some stable APIs to work on. Now, these 12 developers, these were folks with a Java background, and they'd been building front ends in Gwt, and some of them were actually back-end folks that wanted to migrate to the front end. And so when they came to Dart, they were really happy to use some of these things that they were very familiar with already, things like types and classes and the sort of corresponding benefits they get from using the IDE, where I get completion, verification, and just a really easy way to navigate the directory structure. So we've had a lot of success and had a very productive experience using Dart on the front end. And we've captured the imagination of a lot of the other teams at Google in doing so. So, last week we announced what we're calling the beta of AngularDart. We think it's ready for you to use because we've actually shipped an application on it. We're calling it beta because doesn't quite have all the features we'd like to have there for 1.0. But in addition to Angular, the Green Tea team themselves have also released a number of open source components, including support for routes and for their persistence layer that runs on streams that's appropriately named Streamy. Maybe we're not very imaginative in naming things, but it's worked out. So I would like to invite you folks to help us build a very strong developer community on Dart and the AngularDart platform. And I'm looking forward to working with you. Thanks very much. Back to you, Lars.
Wow. I hope you are as impressed as I am. I think this is fantastic to see successful projects working on this platform. So the highlights after these 3 great projects have been demonstrated here is that Dart is ready. It was actually ready a while back, and you can see that people have shipped stuff on it. We have a fantastic programming language. One thing about programming language, you cannot win them all. There's always religion about one programming language is better than the other one, but I think we have hit the sweet spot. So if you're really just interested in productivity and structure, Dart is actually a very good choice. We have good libraries, and what we heard from all our projects is that the programmer productivity is fantastic. They really benefit from the fast turnaround cycle and the consistent set of libraries, and the community, which is great. Next slide. I always do performance slides, so you'll also get that today. So, is it fast? And the answer is yes, sometimes. I decided to compare 3 different systems or platforms today. One is V8, where we run a benchmark written for JavaScript. The other one is a Dart benchmark running on V8 after it has been translated to JavaScript. And the last environment is the Dart benchmark running on the Dart VM. And I've selected for today's presentation 3 benchmarks, standard benchmarks that have been used since the dawn of object-oriented virtual machines. So we have converted that to JavaScript and Dart. One is Delta Blue, a one-way constraint solver that's created by John Maloney a long time ago. Richards, which is an OS simulation benchmark, and Tracer, a ray trace program by Adam. So the interesting part is that we've used these benchmarks to optimize HotSpot, V8, and now Dart. So it might be interesting to look at. Next slide, please. So here are the numbers. So this number has been computed on a desktop system. All the numbers versions are on the right. The blue columns are the JavaScript benchmarks running on top of V8. And we have normalized the number, so this is ×1. So you can see that if we have the Dart version compiled to JavaScript and running on top of V8, they're actually faster, which is great for Delta Blue, a little bit slower for Richards, and a little bit slower for Tracer. That means that even though we translate Dart to JavaScript, you have comparable speed, which is nice. So you don't lose performance when doing that transition. However, if you run on top of the Dart virtual machine, you can get as fast as twice as fast as JavaScript. And this is what we are aiming at with the native Dart implementation. Now, V8 is also from Google, and we used to work on V8. And in the process of making faster speed for the Dart VM, the V8 team has noticed it too. So when we get a speed up in our VM, they look at our CLs and backport it to V8. So we have an internal competition going on, but we still believe we can get twice as fast as them. So anyways, it's not bad. This will actually mean that when the Dart VM gets into Chrome, suddenly you get a speed up of factor of 2 for your Dart application. Next slide. I already talked about this. Great speed with the Dart VM, comparable speed if you translate to JavaScript. One thing I didn't talk about is that there's another kind of performance. What I showed you before was runtime performance, but there's also startup performance. And one thing that's a little bit slow when you run on the web is startup performance. It takes a while to start up the web app. One of the reasons for that is you have to pass all the source code whenever you start up the application. So if you run an application like Gmail, where you have 500,000 lines of JavaScript code, it can take up to a second, even on a fast machine. In the Dart VM, we have a snapshot mechanism like that was implemented for Smalltalk a long time ago, or for Lisp systems. And it actually gives a speed up of a factor of 10. So when you can take advantage of the Dart VM, we can then show that the startup performance is 10 times faster. I think that's impressive. Next slide. So far, we've been talking about using Dart in a web setting for writing web applications. But Dart is a general programming language, and we have also used Dart outside the browser. So you can use Dart as a standalone system. You can either use it for command line tools. One example is the Dart to JS program that is written in Dart. But we can also use it for writing server-side applications. So we have standalone libraries for asynchronous file operations and handling processes and so on. And we support a variety of CPUs, as you can see here, ARM, MIPS, and Intel. So if you want to run on your small embedded ARM device, Dart as a server-side application, you can actually do that. We've been using the server side for our internal performance tracking infrastructure. So it's fairly robust. It's been running for the last 1.5 years, so not bad. It's sort of on the side, but it's good. Thank you. So this is about 1.0, but it's always nice to put in some breadcrumbs for the future. So I talked about the Chromium has now a variant with a native Dart VM. In the future, you'll see it inside Chrome. We're working hard on doing that. There's one obstacle before we can make that happen, and that is to change the memory management system of the DOM. How many knows about the DOM structure and how is garbage collected? Not many? Anyways, it's reference counted, and everybody knows that reference counting is bad. So we're changing the reference counting in the DOM to be trace-based, and that will allow us to get the Dart VM into Chrome without causing memory leaks. So this will happen first. So expect next year sometime that you will have a stable version of Chrome with the Dart VM that will give the extra speed up and the extra startup performance. We are also in the process of standardizing the programming language Dart. We have a spec ready, and I expect in a few months to have that in a committee so people that are interested in improving the programming language, they can sign up and help evolve the language over time. And of course, you heard about AngularDart. It's in beta now, but soon it will be ready when they have all the features in. And we also have a system called Polymer.Dart that follows the Polymer.js future web components, and that will certainly also go stable in near future. And since we are the implementers of speed, you should expect it to get even faster and smaller over time. That I can guarantee you. Next slide. We are getting fairly close to the end. So when you leave this room, I hope you have only one thing on your mind, and that is to go try it out because it's really cool. Download it on either OS X, Linux, or Windows. Everything is completely fully open source. So you can look in how we implemented it, and you can even contribute if you feel like doing that. So that is the talk, except I will talk about some of the partners. We have a list of partners here going all the way from healthcare companies to Google Fiber to Angular and others that are already using Dart, and I hope your companies will soon join the team. And one thing that's good about this community here, people feel encouraged to share components they can share with the web, and people can take advantage of it when building their apps in the future. Next slide. So today, there'll be other sessions that relates to Dart. First of all, there will be an Ask Us Anything kind of session at 1:10 in room 6. And there will be at least 10 Darters. So come with all your questions. And we will have a happy hour session tonight at the Hollywood Cafe. And you can get tickets at the booth if you sort of act interested in the system. That's it. You don't get more today. So I hope you will show up at the booth later today and talk to us about it, or even try it out. And if you have some questions about using it, please ask. Thank you very much.
Thank you. Congratulations.